Okay, is everyone ready for the next talk?
Not yet. I need to.
No, Laci is not yet ready.
How to show presenter notes.
Just let me know if you're ready.
No internet.
Do you need internet?
No, I'll just connect to my phone.
Okay.
Do you know how to show the presenter notes in Keynote?
Yes. A bit of a technical challenge.
Yeah, but in the... who knows how to display presenter notes when in presenter mode in Keynote?
So who is a Keynote expert? We have a Keynote expert.
Oh, not on this.
No. So is there someone who can solve this problem?
All right, problem is solved.
Solved.
Cool.
Okay, now I hand it over to you, Laszlo.
Thanks very much. I always wanted to try how to test in real-life production without any preparation, so here I am, Slim Shady in the house. So now that we've got a little bit refreshed, yeah, my name's László Szűcs. Thank you for the opportunity to present. Thank you for Balázs's presentation and Bill's presentation. I made some mental notes to myself because I will be talking about some stuff that resonates with what they have already told, specifically on how you have to empathize with each other, not just the users, but the developers, and how certain design decisions might be rejected, so to say, by the developers, and what is the background behind these developer decisions. The goal of my talk is to help you understand the hype around AI code generation from Figma to production, its place and its limitations in general. Who am I? I help software engineers become their best possible selves. I train and mentor software engineers at companies, usually with this technological stack, Java, JavaScript, Spring, React, and Angular. In case the big blue giant is listening, I am open for partnership. Occasionally, I am involved in UX-related stuff. I gave a guest presentation at a UX bootcamp. The topic is front-end feasibility, and it covers lots of interesting topics connected to what Balázs touched. And I'm not a robot, I pinky promise. So, today's topics. We will learn about current trends in the motivation behind these trends, specifically code generation and artificial intelligence as mentioned. We will talk about the development process, because in order to understand these trends and their implications on our everyday work, we will have to learn about the practice in general. Also, we will learn about tools, how to use them, and we will learn about Figma. I will talk about Figma, but not just Figma. So everything I say, it can be applied in general sense, not just Figma. But for the sake of simplicity, we have put this into a Figma context. So let's talk about trends, baby. Let's talk about you and me. Code generation. Code generation is not new. In fact, visual tools existed long before. Nowadays, these were drag and drop tools with point and click modeling options. The goal was to be able to create software without having any programming skills. But basically what these were was configurable software-based solutions, configurable software solutions based on templates and predefined building blocks or components, if you like it to put it that way. A related trend of today is low-code and no-code platforms, which is basically a template-based point-and-click programming on steroids. Also, regarding artificial intelligence, we can say that it is also not new. Huge advancements have been made in recent years, and thanks to these advancements that specifically focus mostly on machine learning, we have made huge results, and the goal was to achieve better than human results at the speed of computers. Well, the holy grail of AI is something called artificial general intelligence. Raise your hands if you've heard the term artificial general intelligence. Okay, thanks. Just wanted to make it interactive. An AI that is indistinguishable from a human thinking, not focusing on a specific task, and can basically learn anything just by experiencing the world. This is what an artificial general intelligence is. Okay, so based on these trends that we see, we have an expectation building up. And thanks to the marketing guys at these Figma plugins and tools, we have this expectation that soon AI-generated web apps will be everywhere. Web apps, AI-generated web apps everywhere with a single click. But soon, however, reality kicks in. So none of these technologies replaced competent software professionals in the past decades, and as far as we can see, they will not even do so in the near future. So neither AI nor code generation is no silver bullet. Certain tasks can be done very well with high efficiency, but not all. Extra work is usually necessary to incorporate generated code. Some development work is thus saved, but some extra developer work is required. So we are sort of like one step forward, one step backward. The more focused the task is, the better the result. I don't know how will I do this because I need my fingers for this next one, so this will be really funny. No, I want to do it the funny way. So what you have to imagine is that you deliver some component generated by Figma or whatever tool, and you have another component generated by Figma, and you give it to your developer, and you need these components to fit together, but however they try, it doesn't fit. So what happens is that the developer needs to make adjustments, and if the developer makes the adjustment, it can fit perfectly. But this adjustment needs to be made. So this is the extra work that is involved in here. So in terms of job safety, which is of high concerns nowadays, a day may come when AI takes our jobs, but this day is not that day. And it is not that day because of the Moravex Paradox. The Moravex Paradox basically states that hard problems are easy and the easy problems are hard. I mean, does that make any sense? Well, what does this mean? Certain things are easy for humans to do, but it is very hard to computationally compute using a computer. And some problems are hard for humans to do because the constraints of our cognitive capacities, but it is very easy for a computer to do because the computer has these almost infinite amount of layers of computation where each abstraction layer abstracts away the complexities of the layer beneath. Okay, so this was just for you. Hard problems are easy and easy problems are hard. Humans understand context and can reason using multiple parameters without serious effort. I mean, we kind of learn this as we grow up, and it kind of is intuitive. Now, it's important to understand that proper reasoning without logical fallacies, that's a completely different thing, okay? That is something that AI is actually better than humans, but notice the pattern here. We have a problem space, like, for example, thinking about something. Humans are better at intuitively thinking in these complicated patterns and multiple parameters, but we are not good at staying on the topic. We can easily be deceived. We can easily be manipulated. Computers, on the other hand, machine learning can also be manipulated. That's another aspect we're not going to talk about now, but let's pretend computers are harder to manipulate. So the point is that there's a big problem space where we can define certain parts that are where we can use machine learning and AI to help us, but there are parts in this problem space which requires actual human presence. And because of this, our jobs are, for now, guaranteed. So in this sense, software development is a hard problem for AI. It's sometimes a hard problem for humans also. That's why I started teaching instead of coding, because I realized the damage being done. So why is software development a hard problem for AI? It's because it's not just coding. It is not just the production of code. Conscious and careful decisions need to be made to ensure the success and sustainability of a software project. Considerable effort is usually spent on automation and other development-related necessities. In fact, much of the development work is not related to feature development. Test code, for example, is roughly, it can be 2 times as much as production code. So to translate this into non-software language, someone working 8 hours a day, they work twice as much on not feature-related development, which is crucial for the delivery of the software itself. So the time it takes to correctly implement a feature is much, much more than you would expect based on just looking on a screen and saying that, oh, well, it's there. What else needs to be done? So feature completeness is not the same as production readiness. And the reason for this is that code needs to meet certain qualities which we call ilities of software. Some examples of ilities of software. Usability. Good design decisions drive the success of a software project that might or might not get you as a surprise. Raise your hands if there's by any chance any UX designers in the room. Okay, cool. Great success. It seems like I don't have to explain this, which is nice because I don't have any notes for it. So, maintainability. Maintainability is one of the dearest concerns of engineers. In fact, this is one of the topics that is very closely connected to Balázs's talk about these layers, about getting the layers right and keeping them tidy, which is often key to making great software that is easy to upgrade and to work with in the long run. And it doesn't get into a slow-down phase when changing the color of a button would require 3 months of work, but not sure, it might be 4. So in order to not get into this position, code needs to be maintainable. And in order to keep the code maintainable, there's lots of extra development effort needed. Another important ility of code is security. So cybercrime, cyber warfare, and cyber terrorism, just to lighten up the mood a little bit, are major security challenges of our time. Generated code may or may not be prepared to mitigate security risks in general, but studies so far do show that AI-generated code poses serious security risks if included without any thought. Also, because the language, the code generators today are basically using training data. These code generators can be trained to effectively generate code that contains security risks. So they can be engineered by a malicious actor so that other people who just see that, oh, here's a free version of the ChatGPT code generation, it's free, I just have to click and download and give permission and next, finish, and my work is going to be done in an instant. these are actual things that you have to think about. So because of these ilities, these are just examples of things software engineers need to consider, you might already see that no, AI-generated code is not going to replace us anytime soon. And this is true for designers also, but right now the topic is how close can we get to production-ready code with these code generators. Decisions. Important decisions need to be made daily in the life cycle of a software project that impact these previously mentioned ilities of software. Making these decisions required a broad understanding of context, implications, and priorities. Again, this is something that humans are better in doing than just an algorithm that was pre-programmed to do something. So we are much better in reacting to these changes. Hi. So some challenges. I need to speed up a little bit. Lots of solutions for a single problem. This is also a challenge. You have to decide which solution is the most suitable for your solution, because not all solutions are equal. Requirements can contradict each other. For example, think about security versus usability. It might be very usable and convenient for the user if they don't have to type their password. But it's a huge security risk. So obviously, finding an optimal solution, balancing out the needs, or the other side of the coin is balancing out the unmet needs, is what we do as engineers and what you do as designers. Because remember the three lenses of design, of desirability, viability, and feasibility, and the optimal design lies in the middle, where you find the design that correctly uses compromise in each dimension to find the optimal solution. That is the goal for us also as software engineers. How can we use AI and code generation to our advantage then? So we can clearly see that it is no wonder cure to all our software development ailments. But then what can we use, what can we do to use it to our advantage? Well, we need to understand the limitation and the use cases. We need to consider the trade-offs and use our tools correctly. What does this mean? In terms of limitations, there are soft limitations and hard limitations. Soft limitations can be solved by technology. They are small inaccuracies in the generated design, or maybe it doesn't support some version of the front-end framework being used, whatever. These can be solved by technology. So in time, someone on the other side of the planet will write a piece of code that will solve that problem eventually. But there are also hard limitations which are imposed by the very nature of the process of code generation and how AI works. Fact 1, code contains bugs. Fact 2, code generators and AI are made of code. So the $40 million question is, who is responsible for any damage caused by AI-generated code? Imagine you own a multi-million-dollar company. Would you bet the safety of your customers, their financial assets, their sensitive medical information, or your hard-earned reputation in general, on AI-generated code in production, written by someone who you don't even know? Of course not. But this is the theory. Let's see some concrete examples. Generated code is usually just a visual representation, so to say an empty shell. It's like the outside of a car without anything inside, without the engine and whatever that makes it actually work and fulfill its purpose. Real code is, on the other hand, is connected to the backend. It has the engine in it. An example would be that product data is not actually loaded in the application in the prototype. I did some spoiler, excuse me moi. It's just hard-coded textual data. Another example is that these generated HTML and CSS and maybe some JavaScript code to make it dynamic It's really just static textual things, hard-coded data. Real code, on the other hand, is dynamic. It is stateful. An example would be if you have a button which should increase a counter, but in your prototype, the counter will not increase, so it does not have any state. However primitive that is the concept of increasing a counter, these generated code usually don't support this. So we can see, recognizing these limitations, we can conclude that the generated code is usually neither complete in terms of functionality, nor it is production ready in terms of quality. Thus, the use cases for code generation, for Figma designs, but whatever other design tool is applicable for this, are the follows. Rapid prototyping, which is very nice. Simple websites with little or no dynamic content, maybe landing pages, personal or small business websites. In these cases, it might be good enough to actually be able to be deployed to production. So the original statement of these, the value statement of these tools might be true in some easy, simple cases. Or maybe to deliver reusable component scaffolding, design system scaffolding to your developers. But again, this most of the time will be just scaffolding, so it also requires extra work. So we need to use the tool correctly. How do these tools work? We need to understand how they work in order to use them correctly. The tool builds up a model inside Figma. This model consists of your frames, the shapes that you put on these frames, the way you group these shapes, the components that you create, and the settings and properties that you set to all of these components. And code is generated from this model. Now, the interesting thing here is that the same design with a different Figma model, so visually you see the same thing, but maybe you group some items differently, or maybe you use different shapes to achieve the same visual appearance. It could generate a different generated code. Another interesting thing, that the same design with the same model with a different tool, that can also result in a different generated code. So what you should do is collaborate with the dev team and check whether how much extra work each way of grouping your items and maybe using the tool, which one requires less extra work, which is easier to work with, which is the one that actually delivers value to them. Because in this scenario, the generated code, the developer is in some sense the user of the generated code, and your aim is to make it desirable for the developer to work with it. Yeah, here's some interesting mathematics of team effort. So the first component here is the effort the designer puts into learning how to use the tool. The second component is the developer putting a unit of effort to actually incorporate the generated code. And on the right side of the equation, you see a theoretical value delivered. So if you put zero effort in learning to use the tool, the actual specific generation tool that you use, if you put zero effort in, the developer will have to put in more than the necessary extra effort, let's say 2 times effort. And then the derived value of using this tool is, let's say, 1. But if both of you put in some effort, you put the effort in to learn how to use the tool, so that the generated code is easy to work with for the developer, then you get the expected result of 2. Does that make sense? Cool. Trade-offs. Sometimes this math gets more skewed. Maybe 1 plus 1 is roughly 1, but maybe less than 1. Maybe 2 plus 1 is just 1.1, and 2 plus 2 is just 1.2. The point of this slide is that we have to recognize that, remember this picture you've seen, your mental model, that we have this problem space, and some things can be done efficiently using AI, some things cannot. Now, the point is that if you start putting effort into trying to solve everything with AI and code generation and all this hyped up stuff, you might put in lots of extra effort, but because the developer also has to put in lots of extra effort, and at the end value just doesn't worth it. It isn't worth it, no matter how hard you try. So sometimes you just have to decide which parts in your development process you use these tools, which parts you don't. So it is completely okay if you use it partially in some parts and not in others. A short review of tools. I promise it's going to be short. These are the main tools I found on the Figma plugin website, which are one of the most popular. Here are some happy comments the tool itself is not specified. If you are really interested, you can look it up. I love it. I rarely give reviews, but this is so incredible. It takes designs from Figma and turns them into real website and apps super easily. So it seems like this is all nice and well. But there are also unhappy voices here. It's like in the real world, for people that work on products that actually make money and have real customers, this is not how software is built. It took me less time to learn HTML, CSS, and React than to understand the code that this plugin is generated. It's an impressive tool, but in my experience, the code is unusable. And my all-time favorite, sorry about that, guys, but how do I uninstall this? So conclusions of this short talk. Generating code from design is a useful tool, but it's better for simple basic requirements and is rarely production ready by itself. In order to maximize the results you can get from using these tools, you should get feedback from the dev team and communicate with them continuously, and you need to put in a conscious effort to use your tool in the best possible way to aid you in these. And our jobs are safe for now. Artificial general intelligence might change that, but in that case, artificial general intelligence is developed. Our jobs are of the least concern. Thank you very much. Hasta la vista, baby.
It was a great talk. I was a bit afraid that I will not give you after the title slide anymore. But thanks for mentioning it again. We have time for 2 questions. Who wants to go first? I'm sorry. You didn't sign for a question?
Feel free to ask, I don't bite.
Okay, so AI is nice and all, but let's switch back one generation. We are right now at the pinnacle of the design system era, and the question is, when we streamline with design systems which constrain designers without the layout, and we'll get into the details, so it's not just you can color anything, suddenly color you want anymore. So do design systems allow automatic code generation, like when you're using a popular framework like material design or carbon, when you make an advertisement for IBM? So do they have code generation for you?
Yes, so if I understand it correctly, the question was that does using design systems and maybe some further advancements together will make this a more powerful tool to streamline this code generation process? Again, for certain aspects, yes. But because even on the front end, there's the possibility of certain, for example, security risks, like strictly client-side injection attacks, etc. Because of this, it's probably not going to be able to be streamlined for all areas of development. So for some areas, probably yes, but even in that case, there will probably be always new kinds of features that are just not covered by the training data set. Of course, further training and further improvements will cover those cases, but then again, new components come into existence, so it's probably going to be each is following the other.
Thanks.
Hello, I have a design system related question as well that you mentioned AI can help us to build a design system. Could you please explain a little bit further what do you mean by that, or which aspect of the design system?
Yeah, so what I was referring to is the fact that because design systems usually contain lots of very simple user interface elements, these elements, many of these elements are not stateful, for example, or if they have some sort of state, that state is also very simple. It is not a big of a technical challenge to generate code that is actually correct, to actually generate the implementation of these design system components. So probably for a large part of the actual implementation of a design system, this code generation can be used. It's mostly seamlessly, as the other question asked, even today. But if it has some complex logic in terms of state, or it's some exotic components, so to say, something very specific to an application use case, not a general thing such as a button or an accordion or a slider or whatever. If it's something exotic, then again, in that case, it's probably going to have limitations or missing functionalities. Did that answer your question? Okay.
Thank you very much, László, for the talk and also for the answers. Round of applause. So, just a couple of announcements and we are ready, and you can drink and talk. I think that you can't eat anymore, I guess. Okay, so I think that you have seen that this building networks, sharing knowledge part of our mission is happening now as well, and it also points out that we are not trying to build networks and share knowledge only amongst designers. We would like to open the doors and talk to other departments and talk to other people as well. And with this, we are continuing this series of bringing in other professions, because next week on Tuesday we will have another meetup at Graphisoft Park, which is about architecture in product design, which will be very interesting, so see you there. And also later in March we will have a movie night for UXers, which will be like, we will connect the UI designers with the UX designers, and we will plan to play a video, which will be, Laci, you are here as well, so Laci is my co-organizer in that, which will be about something very special techy thing, and we will talk about how that special techy thing would change our current world or current imagination. So kind of a speculative design event later in March. And with that, I think I finished all the announcements. Peter, is there anything else? Hope there is not. So thank you very much for being here. Thank you very much for bearing with the air conditioning system Hope you liked it, and see you next week. Thank you.